Hi guys, ako nga pala ulit si Ramil Magbo from IT2102 and today I will discuss the CNA1 chapter 5 and titled Ethernet. The OSI physical layer provides the means to transport the bits that make up a data link layer frame across the network region. Ethernet now is the predominant LAN technology in the world. Ethernet operates in data link layer and the physical layer. The Ethernet Protocol standards defines many aspects of network communication, including frame format, frame size, timing, and encoding. When messages are sent between hosts on an Ethernet or Ethernet network, the host format the message into the frame layout that is specified by the standards. The Ethernet frames. What is the Ethernet frames? It is the minimum Ethernet frame size is 64 bytes and the maximum is the 1518 bytes. It includes all bytes from the destination MAC address through the frame check sequence or the FCS field. The preamble field is not included when describing the size of the frame. With the preamble and start frame delimiter fields, it is the 7 bytes that are used to synchronizing between the sending and receiving devices. The destination is the 6-byte field and it is assists in determining if a frame is addressed to them. And the source is the 6-byte that identifies the frame originating NIC or interface must be unicast address. And the ether type, it is the 2-byte field that identifies the upper layer protocol encapsulated in the Ethernet frame. The third is the data field. It is the contains of 46 to 15 bytes that encapsulate data from a higher layer. And the FCS or the frame check sequence field. It is a field that 4 bytes that used to detect errors in a frame. We're going to have an activity. The first one is the MAC and the LLC sublayer entitled the instruction. Description of the MAC and LLC sublayers are provided in the table. Click in the MAC or the LLC fields to match the description to the correct sublayer. The first one is the controls the network interface through the software drivers. It is the LLC. Works with the upper layer to add application information for delivery of data to higher level protocols. It is a LLC. Works with hardware to support bandwidth requirements and check errors in the bit sent and received. It is the MAC. Controls access to the media through signaling and physical misunderstands requirements. It is MAC. Supports Ethernet technology by using CSMA or the CD or CA. It is a MAC. Remains relatively independent of physical equipment. It is LLC. Let's check. It's all correct. Let's proceed to the next activity. The Ethernet frame fields. It is the frame fields that we're going to use is the description. We're going to drag it to the field that have a description. The first description is the use pad to increase this frame field to at least 64 bytes. It is 802 or the header and data. Describe which higher layer protocol has been used. It is a type the frame originating NIC or interface address or the MAC address. It is a source address. Assist host in determining if a frame received to is to address it's the destination. Notifies destination to get ready for a new frame. It is a preamble. Synchronizing sending and receiving devices. It is the start of frame delimiter. And the last is the frame check sequence that detects errors in the Ethernet frame. Let's check. It's all correct. Let's proceed to the second figures that we're going to have the IEE 802.3 Ethernet frame speeds, the 7 bytes, 1 byte, 6 bytes, 6 bytes, 2 bytes, 46 to 15 bytes, and 4 bytes. The instruction is to drag this frame field's name to its correct location in the diagram. Let's going to have the 7 bytes. It is a preamble. The second one is the 1 byte is the start, and next is destination address. The second one is source. The 2 bytes is source. No. This is the length. And the 802 header and data for the frame check. Let's check. It's all correct. Let's proceed to the next activity. The frame forwarding methods or the store and forward cut through. We're going to have a little background. Okay, this is the background. The store and forward. Store forward switch receives the enter frame and computes the CRI. It's look up the destination address, which determine the outgoing interface, and the cut through is the frame before it is entirely received. The cut through switching is the switch acts upon the data as soon as it's received. The memory buffering on switching. An internet switch may use a buffering technique to store frames before forwarding them. The first one is the port-based memory and the second one is the shared memory. The port-based is the memory buffering frames are stored in quicks that are linked to specific incoming and outgoing ports. The second one is the shared is the deposits all frame into a common memory buffer. Now we're going to do the activity now. The first one is the buffers frames until the full frame has been received by the switch. It is the store and forward. Checks the frame for errors before releasing it out on its switch ports. The full frame was not received. The switch discard it. Is this the store and forward? No error checking on frames is performed by the switch before releasing the frame out of its port. It is the cut-through. A great method to use to conserve bandwidth in your network. It is a store and forward. And the destination network interface card or the NIC discard any incomplete frames using the frames forwarding method. It is a cut-through. The faster switching method but may produce more errors in data integrity, therefore more bandwidth may be consumed. It is a cut-through. Let's check. That's all correct. Let's proceed to the second one or the last activity that we're going to do. This is entitled the frame forwarding methods, and this is the illustration we're going to tackle or describe this how it works. The instruction: read the scenario. This is the scenario based on the topology shown. Identify how frames will be processed by dragging your answer to the appropriate fields. We're going to drag it to the blanks. The first one is cabling used is in the topology will be the straight through. To find where PC2 is located, PC1 will be sent out the data frame. It is broadcast. PC2 will respond back to the presenting back a message. It is a uniscast. If a PC2 receives only half of the data in the frames, we're going to discard it. And if receives many damaged frames, it is the store forward because of the Changing back to switching. Let's check. It's all correct. Where this is the last activity. We're going to have a summary. Summary is the most Ethernet is the most widely used LAN technology today. It is a family of networking technologies that are defined in IEEE 802.2 and 802.3 standards, and the Internet defines both the layer 2 protocols and the layer 1 technologies. For the layer 2 protocols, as with all 802 IEEE standards, Ethernet relies on the people, or rather the two separate sublayer of the data link layer to operate the logical link control, or the LLC, and the sublayers.